Hi everyone, so this is my second capstone project for M2M Tech Core 2. I decided to do a clustering analysis of a retail customer dataset. So the first thing I did was to import the required libraries and import the dataset, and also on a high level understand what the data info look like. And then I went ahead to, because I already see from here that there are some null values, so the first thing I did was to drop off the nulls. And then after that, I wanted to use the describe function to check what the data looked like for each of the columns, and I could see already in the quantity column that there was a negative value. So I decided that I would want to view that data so that I know why. And then I did a bar plot, and I could see that quantity had negative values, and well, in retail this could actually indicate like returns, like people that returned some items. So I decided to remove the negative values, and then I now have a better data set. So the next thing I did was to check the data types, and I saw that the invoice date was object, and I decided to convert to a date time because I wanted to use it for further analysis. So I converted the invoice to date time. So I converted the invoice date to date time, and then also calculated the total amount spent, which is basically the quantity multiplied by the unit price, and also created the total amount data frame for on a customer ID level. And then I joined that to the big data set. So for the data set, in addition, I also created two new columns: day of week, and then the month, and then day of week integer from the invoice date. So it's basically using the invoice date, actual invoice date, to work out what day of week was it, to see if there's any trend. So I did that as well. And then I used the KDE plot to check the density of the amount spent. I could already see that it is left skewed. And then I wanted to check the distribution for day of week, and I saw also from day of week that one of the days seems to have no data. Turns out to be Saturday, so maybe in this data set there was no sale happening on Saturday. Yeah, so this is it. And then I went ahead to do also check for the month column that I created, month count. I wanted to check the distribution per month. Turns out that most of the spending was happening in the 11th month. And then finally I wanted to do like a trend to understand the trend of daily spend in the data set, and I plotted the line plot for this for date and amount spent, and I could see that yes, it seems fairly stable, and then it starts to climb up a bit at the end of September 2011, and it kind of remains like that. And then finally I did a country grouping to know what countries were spending more. But then again, it turns out that because the data is skewed and in favor of United Kingdom, so most of the amounts that was being spent were actually from the United Kingdom. And then I wanted to also check the stocks. So the stocks were like the items that were being sold in this retail store, and then I realized also that the top 5 stocks the top 5 stocks were actually these 5 items. This is the description. So the next thing I wanted to do was to do an analysis for the behavior of the data of the customers, and there's this technique that is used for behavior analysis. So especially for customers to understand, it's basically recency, frequency, and spend, or what you call monetary model. So this works by calculating the recency, which is basically the last time the customer bought something, and the frequency, how often they bought something, and the spend, which is basically how much they are spending. So this is the recency, which is basically the date difference between the last transaction date and the max invoice date in the data set. And then this is the recency data frame. And then the frequency is basically the count of on the customer ID level, the count of invoices that each customer had. Again, it's just count, and this is what the data set looked like. And then finally the spend, which is basically a group of the amount that each customer is spending overall, and this is what it looked like, spend. So I merged those three data sets together, and then I have this. And then I wanted to check if there were outliers in this recency frequency spend data frame, and then I used the box plots to view that, and I saw that there were outliers for frequency and spend. And then I also wanted to look at this on the scatter plots, and I could see clearly that for frequency and spend there were like some outliers. So the next thing was to figure out a way to drop off these outliers using a statistical measure called z-scores. So z-scores are used to identify outliers in feature, and then calculate them based on certain metrics and then drop them off. So what I did was, eventually when I had used the z-score method to calculate this, I found out that there were about 29 outliers in frequency and 31 in spend, and then I decided to drop them off from the data set before using them to train the k-means cross-train model. So after doing that, I scaled the RFS data frame, and then I went ahead to use import k-means to calculate the inertia for the k-means model. So to know the number of clusters to use, I use this visualization from Yellow Brick to understand how many clusters do we really need to be for this to train this data set. So it turned out to be 4, and you can already see that the line starts to straighten from the point where k equals to 4. So I did that, and then I used 4 clusters and then trained the k-means, initiated the k-means method and trained on the data and fitted the data on it, and then I got and then I did use the predict method to predict the cluster for each of the customers in the data set based on recency, frequency, spend. And then you can already see that we have this customer ID, cluster 1, cluster 2, cluster 3. So I wanted to look at, for each cluster, I wanted to look at just to view what each cluster looked like based on each feature. So for the first thing I did was for recency and for spend, I wanted to look at the scatter plot, and you can already see for recency and for spend, cluster 0, we have more of them have here. Cluster 1, the green, some of them are here. Cluster 2, cluster 3. And then I also did, and what this tells me already is that recencies, like these people in cluster 0, have not really spent in the last at least 150 days. In cluster 1, some of them have been spending in the last 100 days thereabout, but they've been spending very low. And cluster 2, it seemed like they are the good customers. They spend more and they spend more. They spend low, but they spend more recently. And then we have the cluster 3, which they are the ones that, like, they spend low and they also spend big, and they they spend a lot of money and they also spend more frequently. So cluster 3 are our ideal customers when it comes to recency. For frequency and spend, I also did a scatter plot to understand each of the clusters, and what you can see is for cluster 0, it's like they spend quite often, but again they spend very low. For cluster 1, they spend quite often and they spend low. Cluster 2, they spend a bit often but they spend low. And then cluster 3, which is our ideal customer, that they spend a lot of money and they also spend it quite often. So yeah, this is the summary. So cluster 0 has high recency, low frequency, low spend. Cluster 1, low recency, high frequency, moderate spend. Cluster 2, low recency, low frequency, low spend. And cluster 3, low recency, high frequency, and high spend. So yeah, I just joined the RFS back to the dataset, and yeah, that's about it for this analysis. These are the top items in each cluster that they spend upon, and then this is the day of the week that they spend most. Each of the clusters spend the most on a Thursday. So I think that's about it for this presentation, and yes, thank you for listening.